Hello, and welcome to the second video of 1-1 variables and expressions. Our objective for this video, I can write algebraic expressions that describe a real-life pattern, most likely in the form of a table. In order to do this, we're going to look at a very specific example and then extrapolate that pattern to do other examples. So, there's a picture of a table, and on that table there is a house of cards, and the height of the house of cards is obviously dependent on two things. The height of the table, which is a constant quantity at 24 inches, and then the height of the house of cards is dependent on the number of layers. If you look at the picture, you can see that each layer is labeled to have 3.5 inches of height. So every new layer, the card house will get 3.5 inches taller. What rule can be used to find the given height? And we're going to represent that as an algebraic expression, so an expression that uses a variable. So if we look at the table, we can see that a two-level house would have a total height of 31. Well, where did that 31 come from? It's going to be the 24 from the table plus 3.5 times 2, because there are two layers. The first layer is 3.5, second layer is 3.5. So a more mathematical way of writing that, instead of 3.5 plus 3.5, is 3.5 times 2. So what happens if I had a third layer? Well, that's 34.5, which is pretty clearly an increase of 3.5 inches from layer 2. But again, we could represent this with the 24 inches for the table height plus 3.5 times 3, because there's 3 layers and 3.5 inches for every layer. Fourth level would give us a height of 38, which is going to be that 24 plus 3.5 times 4, because every layer is now 4. There's 4 layers, and it's 3.5 for each layer. So what if I kept building? What if I went to 100 or a million? What if I went to n? So you can see from the table there's a pattern. It's always that plus 24 at the back, and it's always 3.5 times the number of layers, because that is going to, every new layer adds a new 3.5. So we can extrapolate this pattern to say, for n number of layers or levels, that number times 3.5 when added to 24 will tell me the total height. So 3.5n plus 24 is our algebraic expression. Let's look at another example that again uses house of cards. So a group of students built another house of cards that had 10 levels. Each card was 4 inches tall, and the height from the floor to the top of the house of cards was 70 inches. How tall would the house of cards be if they built an 11th level? So initially it might feel like we might not have enough information to solve this, because we don't know the height of the table, except for if you read the problem, it says the height from the floor. So the cards are actually stacked on the floor, and 10 levels are already built. Every level is 4 inches tall. So what do we do? To add that 11th layer, well, that'd just be another 4 inches. So 70 plus 4, or 74 total inches. Second question. Another group of students built a third house of cards with n levels. Each card was 5 inches tall, and the height from the floor to the top of the house of cards was 34 plus 5n inches. How tall would the house of cards be if the group added one more level to the cards? Well, we already know it's 34 plus 5n, and that constant amount of 34 means that bottom level is at least 34 inches, is exactly 34 inches off the ground. So that tells us the table's 34 inches, and 5n, 5 is the number of inches each new level counts for, because the cards are 5 inches tall, and n represents the number of levels. So if I were to add one more level of cards to that current 34 plus 5n, well, that would give me 35 plus 5n plus 5, or 40 plus 5n, because 35 and 5 are like terms, and we can combine those.